Here is another rational equation. 3p over p minus 5 minus 2 over p plus 3 equals p over p plus 3. So looking at my denominators, I have two different pieces, p minus 5 and p plus 3. So my first fraction is missing p plus 3. So I'm going to multiply top and bottom by that. My second fraction is missing p minus 5. So I'm going to multiply top and bottom by that. And my last fraction is also missing p minus 5. So I'm going to multiply top and bottom by that. So I have 3p times p plus 3 over p plus 3 times p minus 5 minus 2 times p minus 5 over p plus 3 times p minus 5 is equal to p times p minus 5 over p plus 3 times p minus 5. If you take a look, all of your denominators are the same, so I can get rid of them. So when I do that, I'm left with 3p, p plus 3, minus 2, p minus 5, equals p times p minus 5. So now from here, I'm going to distribute. When I distribute, I get 3p squared plus 9p minus 2p plus 10 is equal to p squared minus 5p. On the left side, I have some like terms, so I'm going to combine them. 3p squared plus 7p plus 10. And then on the right side, I'm just going to bring it down. I have a p squared. So whenever we have a variable squared, that means I have a quadratic. So in order to solve a quadratic, I'm going to set it equal to 0. So I'm going to move everything over to the left side. So I'm going to subtract p squared on both sides. And in the same step, I'm going to add 5p to both sides. So when I do this, the right side is going to cancel and give me 0. On the left side, 3p squared minus p squared gives me 2p squared, plus 7p plus 5p gives me 12p, and then I'm going to bring down my plus 10. So now I want to see if I can factor. They all have a GCF of 2. So if I take out a 2, I'm left with p squared plus 6p plus 5 equals 0. Now I'm going to continue factoring. I have three terms, so I'm going to use AM, keeping my 2 on the outside, set up 2 sets of parentheses, bring down the first sign of a positive times a positive is a positive for my second sign, and then I want to multiply to 5. The only factors that multiply to 5 are 5 and 1, which also add to 6, so that works. Now I'm going to tee off. I'm going to get p equals -1 and p equals -5. Now remember, you always want to check to see if your denominator is equal to 0, because that's not allowed, it's undefined. But -5 and -1 both work out, so my solution set is -5, comma, -1. Remember, if one of them were to make your denominator 0, you would reject that solution, and you would only have one solution. Or if both of them made the denominators equal to 0, you would reject both of them and get no solution.